Now that you can identify the limiting reactant and the excess reactant and calculate how much product is formed, now you can go back and figure out how much extra excess reactant you'll have left over. Before we look at it from a chemistry perspective, let's go back to the bicycle analogy and answer some questions about how much of those bicycle parts we have left over. So we know that the limiting reactant was our wheels, and we know that we could make 4 bicycles. My question to you is, how many extra parts are we going to have left after we build bicycles? Now, what I want you to do is I want you to solve for these extra parts. I want you to figure out how many extra parts you have. Write down your answers. And most importantly, more important than the answer, I want you to try to record or write down as much as you can about the procedure that you did to figure that out. What process did you need to figure out how many extra pieces you had left over? Because we will use that same process and apply it to a chemical reaction. So pause the video and answer that question. How many extra pieces will you have left over? So this is how I'm guessing you probably solved this problem, or at least a procedure similar to this. What you did is you knew that you could make 4 bicycles. So if we look at just the frames, all right, if we can make 4 bicycles, you're only going to need 4 frames. So you solve for what you need and you subtract from what you have. Okay, so if we only need 4 frames, but we have 5, we have an extra frame left over. All right, if we are making 4 bicycles, we're only going to need 4 seats. So we're going to have 2 seats left over because we are given 6 and we only need 4. So we'll have 2 seats left over. Now, if we're making 4 bicycles, we're only going to need 8 pedals. We are given 15 pedals, but we only need 8. So we are going to have 7 pedals left over. We're subtracting here. Now, the last one is if we're making 4 bicycles, we are going to need 8 wheels. And this should just confirm that we're correct with our limiting reactant. All of those wheels get used up. We have 0 wheels left over. We're given 8 wheels, and we used 8 wheels. So we have 0 wheels left. And that just proves that the wheels was our limiting reactant. The other reactants we have extra of. These are the excess reactants. And we were able to figure out how much extra of each one we had. Let's just jot down a real quick informal procedure here. We take our known product, okay? Let's just say it's our 4 bicycles, and we solve for the amount of an excess reactant. By the way, that known product is going to be our A. And we solve for the amount needed of one of our excess reactants. So that's going to be B. We'll just say that it's frames for the purpose of writing out a procedure. Okay, so this is going to be our 4 frames. So that will be our B. So we take the known amount of product from our reaction, solve for the amount of excess reactant needed. That's going to be our B. So we solved for frames in this example, and we got 4 frames. Now that's how much we need. We know we need 4 frames. So we have 5 frames, but we need 4 frames. This leads us to a subtraction problem. So we are given 5 frames. 5 frames are given to us. And we need 4 frames. So 4 frames are needed. We take what we're given, we subtract what are needed, and we are left over with 1. We have 1 frame left over. So the last step is going to be a subtraction step where we take our given minus our needed. Now the given is what we have in our problem, and the needed is what we just got done calculating. So if you're wondering where to put each one, you should always end up with a positive number. You should always end up with a positive amount extra if that truly is your excess reactant. So let's apply this to a chemistry problem, the same chemistry problem in the last video. We figured out that we could make 9 grams of water when we combined 2 grams of hydrogen gas and 8 grams of oxygen gas. The oxygen gas was our limiting reactant. That limited how much water we could make. we will have extra hydrogen gas left over because hydrogen gas is our excess reactant. So now we're going to figure out how much extra hydrogen gas remains after this reaction. So what we're going to do is we're going to start out with our balanced equation. Now, this is a chemical reaction, so we need a balanced equation for this. So remember, hydrogen gas, H2, and oxygen gas, O2, combine. It's a synthesis reaction. They combine to form water. We are going to balance this equation because we will need those ratios. We need to know how many hydrogens react with how many oxygens and how many waters are created. So it's a 2 to 1 to 2 ratio of that. So the next step is we're going to start with our product, our known amount of product. So water is going to be our A. All right, then we are going to solve for our excess reactant. So H2, or hydrogen gas, is going to be our B. Okay, we know we can make 9 grams of water. So we're going to figure out how many grams of hydrogen we will need for that reaction. So we're going to set up a normal mass to mass or grams to grams stoichiometry problem. So we start with our 9 grams. That's how much water we can make, 9 grams of water. We're going to divide by the molar mass of water, or multiply by 1 mole of water over 18 grams of water. I got this value using the periodic table. 16 is an oxygen, and a hydrogen is 1, and another hydrogen is another 1. That gives us 18. Then we're going to multiply by the coefficient of B over the coefficient of A. Well, this is just a 2 to 2 ratio. So 2 moles of hydrogen make 2 moles of water. And then the last step is to multiply by the molar mass of hydrogen. So H2, hydrogen gas is H2, so it's 2.0 grams per mole. So I multiply all of this out, and I get 1.0 grams of H2 hydrogen gas. By the way, this amount is the amount that I need to make those 9 grams of water. This amount should always be less than what you're given because you're solving for the excess reactant, meaning you're always going to be given more than what you need. So what I would do is, if you're ever asked to solve these types of problems, make sure you label everything very carefully. So you need 1.0 grams of hydrogen gas, and you have 2 grams of hydrogen gas. So we are going to be given more than what we need. The last step to figure out how much extra we have is a subtraction step. So I'm going to take my 2 grams, my 2.0 grams of hydrogen gas that I am given, and I'm going to subtract the 1.0 grams of hydrogen gas that I need, and I'm going to get 1.0 grams of hydrogen gas. That's how much extra gas will be floating around in this container after the reaction is complete. Now remember, all the oxygen got used up because that's our limiting reactant. We do have a little bit extra hydrogen left over that went unreacted.